Hello, my name is Randall Harper, and today we're discussing the wonderful world of... Ow! What the friction?
Reactions.
There are many kinds of reactions, like when you fail your chem test, when your turtle gets run over by a car, or when David dumps you. But reactions in chem are a bit different.
This is a chemical equation for a chemical reaction. One of the important aspects of this reaction is the subscripts. The subscripts tell how much of a particular atom are in the reaction.
The coefficients of the atom state how many moles are for each compound to balance the equation. The law of conservation of mass and conservation of atoms state the mass and atoms on one side have to equal the other side.
I can't figure out if this homework.
What do these numbers in this chemical equation mean?
I don't know.
To the laboratory!
I figured out the chemical reaction, but what do I do with these coefficients?
Well, you see,
No, because this is...
there's two NAs here and one here. So you're gonna have to make this a 2. So they're the equal amount. Now you have 4 on this side, but only 3 here. So you're gonna have to add another 2. But that makes even more H's. So this is gonna have to be a 4. And this is a 2. And now there's 4 NAs, 6 oxygens, 6 oxygens, and 4 H's on both sides.
It's balanced.
Is that really it?
No. There's so much more in chemistry. Now that you know how to balance an equation, let's learn about the different types. First one is synthesis. Synthesis is when 2 elements or compounds come together to form one.
Go!
Decomposition is quite opposite. It is when one compound breaks or decomposes, ooh, you see me, into 2.
Go!
Single replacement is what often happens to our good friend Randall Harper.
Can we not talk about that, please? David.
Single replacement is when you have A, B plus C, and C swoops in and takes A and leaves B all alone.
In other words, the infamous world-renowned chemistry scholar Leslie Workington stated, "This bitch stole the boyfriend."
It's not you. It's Peyton.
It's like double replacement is when you have AB plus C, D, and they switch. A, D plus C, B. Make sure that when you do this switch, you still have metals and non-metals grouping together.
The last type of chemical equation is a quite quirky one. It is combustion. It is when X amount of carbons and hydrogens, and sometimes oxygen, reacts with O2 to form carbon dioxide and water. There are 3 major kinds of double replacement reactions. The first kind is a precipitate reaction, where the precipitate drives the reaction.
What's a precipitate?
A precipitate is a solid formed in a solution after it reacts. Precipitate reactions take place when 2 aqueous substances react to form a solid precipitate and another aqueous substance. As shown in this, there are 2 little guys inside a solution, and then they react with each other and form some more little guys, but a solid precipitate. One thing to note about precipitate-driven reactions is that all group 1 elements and all nitrate groups are always soluble.
The second type of double replacement reactions is neutralization, and it's driven by the formation of a pure liquid like H2O. Like in this equation, you have MgOH2 plus 2HCl, and it creates MgCl and 2H2.
I'll let my student take this one.
In a gas formation reaction, the reaction is driven by the gas.
Another important part of learning chemical reactions is figuring out how to do net ionic equations. You have here the basic chemical equation with all this jazz, which is highly unuseful. So, you have some spectator ions that, if you think about it, they don't do anything. So, you can get rid of that and get rid of that, because why do we need this guy? It's a spectator ion. It just sits there and chills and does all that stuff. So after you get rid of all the spectator ions in the equation, you are left with the net ionic equation. The net ionic is all of the substances that actually take place in the reaction. In order to learn how to write chemical reactions, first, you have to learn the prefixes. Di would mean 2, tri would mean 3, and so on. So, for this, it would be sulfur burns in oxygen, so plus O, to make sulfur dioxide, which is 2 oxygens.
To go from the number equation to the words equation, you write mercury oxide, because when they're combined you add IDE at the end to make mercury and oxygen.
To get to the net ionic equation, first you have a normal molecular equation. We are going to be using 2KCl plus PbNO3 2 goes to 2KNO3 plus. So, we have our molecular equation. Now, we should probably put it into a molecular ionic equation. To transfer this equation into a complete ionic equation, there would be 2 K pluses, 2 Cl minuses, which is this compound, plus Pb2 plus, and 2, and then the products would be 2K plus 2NO3 minus plus PbCl2. Now that you have your complete ionic equation, you can see which ones are spectator ions. Spectator ions stay the same throughout the reaction and do not do anything to drive it. So, 2K plus and 2K plus stays the same. It does nothing. 2NO3 and 2NO3 also stay the same. So, now you have your net ionic equation, which would be 2Cl minus plus Pb2 plus goes to PbCl2. If you want to predict what your reactions will produce, first establish what kind of reaction it will be. These have 2 lone substances, so it must be synthesis, which means they combined to form LIN. To form Li3N. This one would be double replacement because there are 2 things combined and then 2 combined here. So it would be Al with NO, NO3 plus Ba with CrO4.
Do you guys get it?
I think I get it.
Really?
No.
That's okay. That's chemistry.
That was a hit, and then Zimmerman catches both of those runners in.